We're going to look at descriptive statistics for grouped and ungrouped data. So we're given data that is scattered. Can somebody tell me what is the first thing you need to do whenever you're given data like this? What is the first thing we need to do?
Arrange it in chronological order, smallest to largest.
Yes, we arrange it in chronological order, starting with the smallest to the biggest. So we have 2, and then
3,
3, then 4,
4,
then
5,
then
7,
then 7, then 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I need all of you to participate here. If you've never answered a question in class, then this should be your chance to. Everyone must say something. Let's go to the range. What is the range? How do you find the range? What is the range? Anyone?
Minus the smallest number.
Maximum value minus the minimum value, right, of x. Maximum value of x minus minimum value of x. What is the maximum value of x here?
9.
9 minus what?
2.
2. You get 7. Okay. Let's go to the quartiles. Okay, before we go to the quartiles, the mode. What is our mode here? What does mode mean? What does mode mean, O'Brien and Paul? Mode means what?
The number appears.
The number that appears, correct? What appears the most here is 7. So that is our mode. Then we go to the quartiles. We have what we call the lower quartile. It's given by Q1. The lower quartile is a quarter of n plus 1. A quarter of n plus 1. N stands for the number of observations. N stands for the number of observations. So how many observations do we have? How many observations do we have?
7.
How many observations do we have? 1, 2, 3, 4, 5, 6, 7. So a quarter of 7 plus 1. So 7 plus 1 is 8. A quarter of 8 is what? A quarter of 8 is 2. So I look at the second number. The second value here will be 1, 2. So this is called our lower quartile. So here we're going to have our 3. Then when we go to the second quartile is also called the median. Simply a quarter, the second quarter over 4, which is same as half. N plus 1. Our n is 7. 7 plus 1 is 8. Half of 8 is 4. So what is the fourth number? The distribution. So fourth number. You count the order.
Number 4. 4. So that's number 5.
That is 5. Good. So that's why it's important to rearrange them. Then we go to the third quarter. It's 3 quarters or 75%. 3 over 4 times n plus 1. 3 quarters of 8 is the 6th number. What is the sixth number here?
Seven.
7. All right, so I think we did this in the first class we had. Just a recap. Then when we go to the quartiles, the difference between the first quartile and the second quartile is called our interquartile range. So here we've established 3, 5, 7. 3, 5. So we can draw a box whisker diagram here. A box whisker diagram based on what we have. Our first quartile is 3. Our second quartile is 5. And our third quartile is 7. Our smallest value is 2, and our highest value is 9. This is called our box whisker plot. So we have what we call the interquartile range, which is the difference between the highest value and the smallest value. So Q3 minus Q1.
There's an error there, people.
Which is a 7 minus 3 to give us a 4. This is called our interquartile range. Semi-quartile deviation is half of the interquartile range. Semi-quartile deviation is half of the interquartile range. Half of the interquartile range, half of 4. 2. This is called our interquartile, semi-quartile deviation. It's 2.
Semi-quartile deviation.
I'll ask for questions if we have any before I proceed. Please speak now or forever hold your peace.
So can I find the interquartile range without doing the box whisker plot? I know I'm able to, but
Yeah,
what's the difference?
Oh, you can find it. That box I'm drawing is when you're asked to draw the box whisker diagram. Otherwise, you don't need the. You just asked to do that.
Okay.
All right. Now, if you are asked to identify the outliers, outliers are the numbers outside this whisker plot. So to find outliers, it's the lower quartile minus 1.5 of the interquartile range. This is the lower value. Upper value is the third quartile plus 1.5 of the correction term. So our interquartile range was 4. So 1.5 times 4. 1.5 times 4. What is 1.5 times 4? 6, isn't it? So the correction term is 6. So we have our lower quartile here, which is 3. So 3 minus 6, we get -3. The upper quartile was 7. So 7 plus 6 get T. So if you're asked to identify an outlier, if you're given, for instance, a number in that sequence of 20, you'll be able to identify the outlier in the sense that these maximum values or minimum values are giving you an allowance within which you can tolerate or accommodate figures. So this means that here we can stretch up until -3. Here we can stretch up until 13. Any numbers outside there will be called outliers. So sometimes the examiner would want you to identify outliers in the list of figures have been given. So you can only find outliers by adding what is called this correction term, 1.5 times the interquartile range. Okay. Are we together so far? The other thing that you'll be asked to find will be the mean, the variance, and the standard deviation. The mean, the variance, and the standard deviation. So if you're given values like, this is another question, 2, 4, 6, 8. Just square them individually. So here we're going to have 4, 16, 36, and 64. And let's total them up. This is 20. This is 120. The sum of x is called summation of x. The sum of x squared is called summation of x squared. The mean is the average. It is denoted by the symbol x bar. So to find the mean, it's simply summation of x over n. N is the number of observations. N here is 4. So to find the mean, 20 over 4, the answer is 5. That is how we find the mean. Find the variance given by the symbol sigma s squared. This is called the population variance, the sigma, and the sample variance is given by s. For a sample like this one, we can use s. Of course, people would want to use them interchangeably. The population is for a big sample. And the sample variance is for a small sample as been given here. The formula for variance are many formulas. Okay, but this one is easier. It's summation of x squared minus summation of x all squared over n, everything over n minus 1. So summation of x squared here is 120. Small x is 20 squared over n over 5, everything over 5 minus 1. So you need to be careful here. You start from this angle here. 20 squared is 400. 400 divided by 5. So I'm going to get 8. We're going to have 120 minus 80 divided by 4. So 100 minus 80 is 40. 40 divided by 4 is 10. 10 is called your variance. Standard deviation, the square root of the variance. What is the square root of 10? 3.1. The square root of 10.
3.162.
162. That is how we find our standard deviation. To find our coefficient of variation, CV, simply standard deviation over mean times 100. So our standard deviation is what we're just calculating, and our mean is the first thing we calculated. Standard deviation 3.162, and our mean 5. So 3.162, put it here. Our mean is 5, put it here. So what answer do you get? As a percentage. So that is
0.63.
Huh?
0.63
63 what?
times 100, so it would be 60.
36. 0.363. So
I
63.
said 0.6.
So 63 point what?
63.24.
Coefficient of variation. We go to our coefficient of skewness. Formula is 3 x bar median
Or
standard deviation. You need to be ready for the exam. You need to master about 98 formulas.
Thank you. That's not intimidating.
So our median is the middle number. Now, before I go to the median, sometimes when you have an even number like this one here, who remembers the formula for the median? The median is the second quartile.
You just find the average of the two.
N plus 1. So our n is 4. 4 plus 1 is 5. 5 divided by 2 is 2.5. Whenever you're getting a 2.5, it means you add the second number and the third number, you divide by 2. All right. If you have a 0.75, you round off to the nearest third number. If you have a 0.25, you round off to the nearest a small number. So 0.25 means the second and the third divided by 2. If you have 2.75, you have just rounded off to the third number. If you have 2.25, you have just rounded off to the second number. So 2.5, the second number and the third number. So 4 plus 6 is 10. 10 divided by 2 is 5. So our median is 5. Our median is 5. Whenever the mean and the median are the same, it means you have a normal distribution. You're going to get a 0 skewness. Now, skewness means or stands for the degree to which your distribution is bending. If you get a positive number, it means bending to the positive side. If you get a negative number, it means it's skewed to the left or negatively skewed. If you get a 0, it's normally distributed. So skewness is also used to ascertain the distribution of bias. If most students pass, it's skewed to the right. Most students fail, it's skewed to the left. If you get a 0, it is normally distributed. So we've gotten a 5 there. So So it means what? Our skewness is 0. So here you can conclude that the distribution is normally distributed. Normally distributed. Okay. So sometimes we also have a scenario where we are given your answers in classes. So we have 1 to 5. We have 6 to 10. Have 11 to what? We have 11 to 15. And we have, I'm in class, can I play back? (11 to 15). And we have 16. You're asked to find the mean. Yeah. Frequency has been given here as 3, 7, 5, 2. So yeah, what we call the cumulative frequency column. Here you keep adding on. So this number we started with is a 3. You add it to 7, we get 10. Add it to 5, we get 15. You add it to the 2, you get 17. This total must always be the same as the total here, 17. And we have what is called the midpoint. So 1 plus 5, 6 divided by 2 is 3. This is what we call the midpoint. We add the lower bound and the upper bound divided by 2. So 6 plus 10 is 16. Divided by 2 is 8. Now the distance from this lower bound to the other lower bound to the other lower bound is what is called the height. Discover that the height is similar even in the midpoint. The difference from here to here is 5. So you can also keep adding another 5 here, you get 13. Another 5 here, you get 18. This tallies well. You can still prove it when you add 11 plus 15, 26 divided by 2, 13. Similarly here, you get this one. So this is called our midpoint. And you can square this. 3 times 3, 9. 8 times 8, 64. 18 plus 6, 13, 169. And what is 18 times 18?
324.
18 times 18? What?
324.
24.
324.
Thank you, 324. Great. Then finally you go to the last 2 columns. Fx. So Fx, multiplying this column and that column. So 3 times 3 is 9. Fx squared, you start again. 3 times 9, 27. The mistake most students want to do is to square this one to get that. So never do that. So 3 times 3, 9. 3 times 9, 27. Again here, we've got 7 times 8, 56. Again, you go to 7 times 64. What are you getting? 8 carry
448.
148?
448.
448. Thank you. Then we go here. 5 times 13. What do we get?
65.
And 5 times 169. What do you get?
845.
Pardon?
845.
45.
845. 845.
845. Here 2 times 18.
36.
Here 6.
648.
Then you are only interested in the parts that have an F. An F. The ones you total. This one we've already totaled. Here, what is the total?
Hundred and 66.
Around 266.
166.
166. The next one.
1968.
Around
1968.
1168.
1968.
1968. Good. So after finding this, our mean for the group data is summation of f x over the frequency. Summation of fx over the frequency. 166 over 17. It's called our mean for group data. And we get
9.6.
4.96.
9. No, 9.76.
9.76. Okay, thank you for that. Then for the variance, the formula is similar except that we are just adding an f. Summation of f over summation of fx all squared, and is the same as summation of f frequency. Some formulas just to put n there, others will put summation of f, everything over summation of f minus 1. So what is summation of fx? 1968. Summation of f 166 squared over 17. Everything divided by 17 minus 1. What are you getting? Remember, I said you start from here. 166 squared over 17. The answer is subtract from there. And the final answer is divide by 16. It's called the variance. What are you getting?
So that will be 347.06 divided by 16.
An answer? What's the final answer?
The final answer is 21.69.
Okay, so we end here. Your homework is the first part of your test. So I will require that work before our next class. So the homework will be question number 1. Please take it seriously.